Okay, let's talk about rings. Rings are in some ways simple and in some ways complex. They are simple because you just count the number of carbons on the ring and then you put cyclo in front of it. So you have this guy right here has 1, 2, 3, 4, 5, 6 carbons, making it cyclohexane. Okay, so it's pretty much just the same as with those branched alkanes, alkenes, and alkynes we've been working on. This one here has 6 carbons, so it's going to be cyclohexene. Now, the difference, or a difference, got to stress that, it's a difference for your cyclohexanes, or your cycloalkanes, alkenes, and so on, is that there's no definite starting point on a ring. With a chain, there's always, the two ends that you're going to start from, one or the other. But there's no starting point on a ring. So the ring is always going to start from the most important spot. Okay. When we start getting into the substituents, the suffix groups, then the suffix group is going to be where you start. Otherwise, you just go with the interesting spot, or whatever gives you the lowest number. Okay, for your for when you number your side chains. Of course, then you have the question: do you count clockwise or counterclockwise? And then again, first time there's a difference. To start, we're not going to have any suffix groups, so that makes it somewhat simple, somewhat complicated. So let's go ahead and look at our first major difference. Not major difference, but major point of conflict. What do you do if you have both a ring and a chain? Because you can't name both simultaneously. Either the ring is a side chain or your chain is a side chain. Okay? Only one of them can be the focus of your attentions. Only one of them gets to be, the main chain. And the rule there is all else being equal, you prefer, that's an awful, you prefer the ring, okay? You give priority to rings over chains, unless there is something on the chain, okay? So if there's a suffix group or there's other substituents, things like that on the chain, you go with the chain. But if they're equal, you go with the ring. Okay? So in this case, all we have is, here's your dividing line, 1, 2, 3 carbons on your chain, and you have 1, 2, 3, 4, 5, 6 carbons on your ring. There's no suffix groups, there's no side groups, there's nothing interesting about either one particularly, so our preference, our priority goes to the ring. So this is going to be a propyl cyclohexane. Okay. So that chain becomes a propyl group, and the main chain is the ring. There's no reason to differentiate between the two. And now, this also gives us something to talk about for the numbering. Because there's only the one group on there, we don't put a number on the ring, or we don't have to say where the propyl group is. In any sort of counting, it will always be, number 1 on that ring. Therefore, propyl cyclohexane. If we have multiple items on our ring, then we are going to have to put numbers on there. Okay, actually, before we continue, I'm going to show you how to draw two rings that show up a lot. Okay, first off, cyclohexane. So cyclohexane, and then the other one is cyclopentane. Okay, so a 6-member ring and a 5-member ring. These are very, very popular in the real world. Biological systems in particular use these sorts of rings all the time. You can get larger or smaller rings, but these two are very, very common, so it helps you to know how to draw them, and draw them so that they look pretty good, and so that organic chemists know what you're talking about, because otherwise the organic chemists will make fun of you. So first up, you draw the hat, which means just, angled line. Then you put the ear flaps on the hat. Okay. So notice that for cyclohexane, the ear flaps come straight down. For cyclopentane, the ear flaps come in. Then you draw the chin strap. Okay. So you draw another angled line for the 6-membered ring. You just draw a straight line for the cyclopentane. And that's all there is to it. That gets you your 6 lines for cyclohexane, your 5 lines for cyclopentane. So nice and simple. Now, hat, your ear flaps, and your chin strap. Okay? And that's how you draw those two rings. They show up a lot, so not too tough. Now, the smallest possible ring, of course, is going to be cyclopropane. Prop means 3, so 1, 2, 3. It's just a triangle. Then you get cyclobutane. 4 makes it a square. So you should be pretty good at drawing those. But the pentagon and the hexagon, cyclopentane and cyclopropane, you might not be as good at. You can go higher, of course. Cycloheptane has 7 sides. And then you can get 1, 2, 3, 4, 5, 6, 7, 8. Cyclooctane, an octagon, would be a stop sign, and so on. It's just a matter of extending what you already know. But these two, cyclohexane, cyclopropane, those are the biggies. Those are the ones you really need to focus on because they show up a lot. But be ready to draw any sort of ring. Okay, moving on. Oops. Okay. So, what if you have multiple things on a ring? Okay. Let's go ahead and draw a nice cyclohexane. Okay. So here, we have a side chain, and another side chain, and another side chain. Well, you just go ahead and you name those as normal. You count the carbons, end them with "il", and then you number them. Okay, so here you have 1, 2, 3 carbons, 1 and 2 and 1. So 1 makes it a methyl side chain. This here is ethyl, and this is prop 2 il. So you put those in your alphabetical order. Ethyl is going to be the one that comes first. So, which one is it going to be? Is it going to be clockwise or counterclockwise? Sunwise or Widdershins? Whichever one comes second is the one that's going to be number 2. Okay? So next up would be methyl. Methyl comes before propyl. So that means 2, 3, 4, 5, and 6. So that means that this is a 1, oops, don't need that circle, 1 ethyl, 2 methyl, methyl, not nethyl, 6 prop 2 il, cyclohexane. Very simple, very straightforward. Just a small advancement on what we've already covered, because now you have to be a little bit more discriminating in terms of what you're going to do with your numbering. You have to choose what place is going to come first, and then you choose which direction you count from there. Now let's look at a ring as a side chain. So let's go ahead. All right. So here we have a nice long chain with a bunch of side chains on it. We choose the longest chain that gives us the most number of side chains, right? It's going to be this guy. This gives us 3 side chains. In terms of numbering, well, we'll worry about that later. First, we need to name our side chains, okay? And naming them is going to be pretty much exactly the same. Cyclohexyl, methylidene, ethyl, and this here is a double bond. So no need to forget about that. Now, when it comes to alphabetizing, you do count the cyclo. Okay, that's part of the name of the side chain, so it's going to start with C. And that makes the cyclohexyl the first one to show up in our numbering. So we are going to number this chain from left to right. 2, 3, 4, 5, 6, 7. So, naming this 2 cyclohexyl, 3 ethyl, 4 methylidene, and then hepta 5 ene, or just just hept 5 ene. So that's the name of this molecule: 2 cyclohexyl, 3 ethyl, 4 methylidene, hepta 5 ene. Okay. Otherwise, we would be trying to name that big old heptane chain as a side chain, which would not be impossible. It would just be annoying, slightly more difficult than otherwise. So we just don't do that. So far, there's nothing particularly difficult about naming our ring system. There will be a few other things we got to come to later, but it really isn't particularly difficult. So let's go ahead and throw an example at you. What is this one named? So go ahead, pause it. This is, just to let you know, there's only 4 carbons on this ring. This right here is a mistake. So it's meant to be just a single line. It's not a double line. It's not a bend. Okay, it's just a single straight line. So go ahead, pause it, try and name it, and then when you come back, I'll go ahead and go through it. Welcome back. All right, so we name each of the side groups, the side chains on this ring. And what we come up with is we have methyl, 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 propyl, methylidine, ethyl, and ethyl. Okay, so one that's going to come first alphabetically is our ethyl groups, which both happen to be on the same carbon. So that makes it nice and simple. So that means that this carbon right here is number 1. So do we go clockwise or counterclockwise? Well, that depends. What comes first? The methyl groups or the methylidines? So going, oh, sorry, there's another methyl group over here. So when we look at our methyl, well, that actually we don't need to worry about the numbering as much as we need to worry about what comes first alphabetically, methyl or methylidine. Nothing always comes before something. So methyl comes before methylidine. Methyl and then methylidine. Yeah, my handwriting is execrable. There's not a whole lot I can do about that writing on a screen like this. So that means that we're going to go clockwise, not counterclockwise. So 2, 3, and 4. So now let's go ahead and name our ring. It is 1, 1 diethyl, 2, 2, 3 trimethyl, 4 methylidine, 3 propyl, cycloalkanes. Okay, there's 4 carbons on there, so that's bute, no double bonds, so ane, and it's a ring, cyclo. Okay, nice and straightforward. Now, before I sign off, I want to stress that rings can get very, 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 very complicated. They are nasty, incredibly nasty, because they can spread out in 3 dimensions. They can be, nice and symmetrical or asymmetrical. You can have rings connected to rings. The rings can overlap. They can be directly bonded to each other. You can get an arch going across a ring. I mean, that 1,500-page book I've told you about, most of it is dedicated to rings. We are barely touching the surface, and you're welcome for that. So, in the meantime, we're gonna stick with the simple thing of just rings with things on, not necessarily definitely not even not necessarily, just definitely not the more complicated stuff. Okay, that will do it for this. I'll see you in class.